Hello students, our today remaining part of the trigonometry will start. In this we will learn domain and range of trigonometric functions. Last class we learned graphical representation of trigonometric functions. Graphical representation of trigonometric functions. So we have trigonometric functions we denoted by y is equal to or f of x is equal to sine theta, cos theta, tan theta, cosecant theta, secant theta, like that, so on will come. So domain range we will see trigonometric function. First we take a trigonometric function. Trigonometric function. So here domain we are considering. Domain. Next finally range. So first if we take a trigonometric function sine. So y is equal to or f of x is equal to y is equal to sine theta. So domain you can take any value, any real number, any real value for theta. For theta belongs to domain is theta. Any value you will get range y or f of x or f of x. So what is the range? So minimum value for trigonometry for sine means, so we got graphically sine wave is like that. So this is 0, 1, minus 1. So these values on x-axis indicate the domain. So values on x-axis domain, any angle you can take, but the range is always oscillating between minus 1 and 1. It is not increasing greater than, it is not increasing 1, exceeding 1, and it is not going below to the minus 1. So the domain of sine is minus 1, 1. Closed interval. Okay. Next, trigonometric function cos. Cos theta. So this for this also, cos theta also it begins with 1. So already we observed in last class. So cos theta start from 1 and like this. The cos wave will go like this. Okay. Here minimum value is minus 1. Maximum value of trigonometric function y is plus 1. So theta is any value you can take. That is real. Theta is a real value, any real value. But minimum value of the cos is minus 1 and maximum value is plus 1 under the closed interval. Next, coming to the next trigonometric function, that is tan. F of x is equal to y is equal to tan theta. So for tan theta, for 90 degrees and multiples of 90 not defined. For 90 and multiples of 90, what we are getting? Infinity we are getting. So at 90 and minus 90 and 270. So like this it is going tan 0, 0 like this. So you see trigonometric functions are coming like this. Like this. So for 90 it is not defined. For value of domain 90, theta is equal to 90, it is not defined. So we are removing that 90. R minus set of odd multiples, no? Odd multiples of 90. 2n plus 1, 5 by 2. 2n plus 1, 5 by 2. We have to remove this one. Where n belongs to integer. Where n belongs to integer. So from real values, we have to subtract the 90 and its multiples. And where n is the integer. Whether this integer is positive or negative, whatever it may be. So multiples of 90 you have to remove because multiples of 90 are multiples of 90. So here range is not defined. So now here we get real values. Range is real value we get. Next, coming to fourth one, that is f of x is equal to y is equal to cosecant theta. So for cosecant theta, at 80. So because it is reciprocal of sine, at 0 degrees 80, its period is 5. This period of this one is 2 pi 2 pi. These periods are pi pi will come. So gap is pi now 90 to 370. So your periods is period of trigonometric function 2 pi here sine or cos. Here pi will come. Okay, pi will come. So in that period, for 0 and the multiples of that one 0, 180, 260 like that. There it is not defined. R minus pi, n pi, for all n belongs to z. For all n belongs to z. So range will come. What values will come here? Two values will come. So minus infinity to 1 and infinity to 1. That values will come. This is period you should remember. Okay, that we will note down. Minus infinity to plus 1. Moving now. So minus infinity to that will come minus 1 and plus 1 to plus infinity. So infinity it is a open bracket. So next function we will see. What is the next function? Fifth one. F of x is equal to y is equal to secant theta. So in this, where secant theta will be not defined at the multiples of 90. Multiples of 90. 90 and the multiples of 90 it is not defined. So multiples of 90 you have to remove here. R minus 2n plus 1 pi by 2. N belongs to z. N belongs to z. N belongs to z. So now here also range is real numbers. Next finally cot we will see. F of x is equal to y is equal to cot theta. So for this multiples of pi for all n belongs to z is not defined in domain. In range, whereas we will get minus infinity to minus 1 union of 1 to plus infinity. This is a closed bracket and open bracket. So this is the domain and range of trigonometric functions. 6 trigonometric ratios. So domain, for this domain range will be defined. So here period of the function. For this all same thing will come. Okay, in the period will get. So next coming to next one. Note it. Note now. Trigonometric identities. So trigonometric identities. We will learn today what are trigonometric identities. Trigonometric identities. Trigonometric identities. So for all values of given theta, the given trigonometric identities should be true. Then only the trigonometric ratios are called identities. First you see, first trigonometric identity, sine square theta plus cos square theta is equal to 1. So where for all theta belongs to any real numbers. Any real number you can take, it is true. Okay, this can be written as further we write the second trigonometric identity, secant square theta minus tan square theta is equal to 1. So here it is defined, it does not define for 90 and multiples of 90. Theta is equal to, already I told no domain, r minus 2n plus 1 pi by 2 for all n belongs to z. For all n belongs to z. Okay, that you should remember. So next, third identity. Cosecant square theta minus cot square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. So you should divide this one also. 90 degrees, tan 90, infinitive rate. So it is not defined for 90 degrees. That is pi by 2 and its multiple. That's why we are remembering. Next here you see cosecant. Cosecant 0 degrees is infinity. For 0 and pi also it is not defined. So now here r minus n pi, r minus n pi for all n belongs to z. For all n belongs to z, it is not. So these are identities. That is, these two are conditional identities. What is the condition? This is the condition for domain of this trigonometric function. For this well, these two are not defined, and these two are not defined for this values. Remaining all values, it is comes 1. So now we will write for sine theta. So sine square theta can be written as 1 minus cos square theta, and sine theta is equal to under root 1 minus cos square theta. Same way, cos theta also we can write cos square theta is equal to 1 minus sin square theta. Cos theta is equal to under root of 1 minus sin square theta. Next, secant. Secant square theta. This is first. Secant square theta is equal to 1 plus tan square theta. Secant theta is equal to under root 1 plus tan square theta. Same way, tan square theta is equal to secant square theta minus 1, and tan theta is equal to under root secant square theta minus 1. And next, cosecant. Cosecant square theta is equal to 1 plus cot square theta. Cosecant theta is equal to 1 plus cot square theta. Total is under root. Next, cot square theta is equal to cosecant square theta minus 1. Cot theta is equal to under root of cosecant square theta minus 1. So in this form we can write these identities. Okay? Any doubt? So next, another form of this identities we will write. Except this first one, these two are we can write in other forms that we will check here. This I am going to work here. See, a square minus b square form. A square minus b square is equal to 1. A plus b into a minus b is equal to 1. So now we can write this one. A plus b is equal to 1 by a minus b, or a minus b is equal to 1 by a plus b. Same way we can write like that. If a is equal to secant theta and tan is equal to b. So a is equal to secant theta and b is equal to tan theta. Then secant theta plus tan theta is equal to 1 by secant theta minus tan theta. Same way, secant theta minus tan theta is equal to 1 by secant theta plus tan theta. Okay? In the same way, third one also we can write another form. You see, here a is equal to cosecant theta B is equal to cot theta. So now cosecant theta plus cot theta is equal to 1 by cosecant theta minus cot theta. Next, cosecant theta minus cot theta is equal to 1 by cosecant theta plus cot theta. Is it clear? So these are the other forms of these trigonometric identities. Okay. Next. Writing the trigonometric ratios into other trigonometric ratios. First we see sine theta. Next cos theta, tan theta, cosecant theta, secant theta, cot theta. So these trigonometric, six trigonometric ratios we are going to write in another trigonometric ratios. First we are going to write this all six trigonometric ratios in terms of sine. Okay, let us see. Sine cos theta, tan theta, cosecant theta. Is it visible? Tan theta can be visible.
Yes.
Secant theta, finally cot theta. So now you see sine in terms of sine, sine only comes. Cos in terms of sine. We have found root of 1 minus sine square theta. Tan in terms of sine. How to write tan in terms of sine? So we can write this in the form of sine theta by cos theta. Here I am going to write the one. Tan in terms of sine. Tan theta is equal to sine theta by cos theta. So here sine theta already we got. We have to write in terms of sine theta. Now numerator we already obtained sine theta. Denominator also we have to convert into sine theta. Cos we can easily convert into sine theta by using identity root of 1 minus sine square theta. So root of 1 minus sine square theta. So this we can write sine theta by under root of 1 minus sine square theta. So tan in terms of sine. Next cosecant in terms of sine. So cosecant in terms of sine we can easily write directly because it is a reciprocal of sine. So 1 by sine theta. So secant in terms of sine. So secant in terms of sine means secant we can write secant theta is equal to 1 by cos theta. Reciprocal of cos. No, cos we can write root of 1 minus sine square theta. Okay. So this can be written as 1 by root of 1 minus sine square theta. Next, cot in terms of sine. So we know that cot theta is equal to cos theta by sine theta. In denominator we already got sine. Numerator we have to convert into sine. So cos in terms of sine is already converted root of 1 minus sine square theta, that is right here. Root of 1 minus sine square theta by sine theta. So this will become cot theta is equal to right. Cot theta is equal to root of 1 minus sine square theta by sine theta. Okay. Next, all the trigonometric functions in terms of cos. 6 trigonometric ratios where wrote in terms of sine. Again here we are writing all 6 trigonometric functions in terms of cos. So now carefully observe how we are going to write that one. So first sine in terms of cos. Sine in terms of cos means root of 1 minus cos square theta by using trigonometric identities. Next, cos in terms of cos, same thing will get cos theta only. Tan in terms of cos, we know that tan theta is equal to sin theta by cos theta. Sin can be written as 1 minus cos square theta by cos theta. So we written in terms of cos now. So root of 1 minus cos square theta by cos theta. So next, cosecant in terms of cos. So cosecant can be written as 1 by sin theta, and sin theta can be written as cosecant theta is the reciprocal of sin theta, and sin can be written as under root 1 minus cos square theta. So now cosecant in terms of cos, 1 by root of 1 minus cos square theta. Okay. Next, secant in terms of cos. Secant is nothing but reciprocal of cos. Secant is nothing but reciprocal of cos. So that is 1 by cos theta, directly we can write. Next, cot in terms of cos. So cot can be written as cos theta by sin theta. Here we have to convert it in denominator sin theta into cos theta. So cos theta by sin can be written as 1 minus cos square theta. So that will become cos theta by root of 1 minus cos square theta. Okay. So all 6 trigonometric ratios were written in the form of cos. Next, we will write all trigonometric ratios in terms of tan. So first, sine in terms of tan. How to write sine in terms of tan? So relation between sine and tan. Now tan. Okay, coming clearly. Now we know that sin theta. Now we are going to write in terms of cos, because cos is the reciprocal of secant. Secant we can easily write in terms of tan by using identity. Secant square theta minus tan square theta is equal to 1. So first sine we have to convert in terms of cos. So that is sine is can be written as root of 1 minus cos square theta. So that is root of 1 minus. So cos is a reciprocal of secant. Secant square theta. Okay. Root of 1 minus 1 by secant square theta. Okay. So this secant square theta can be written as in the form of tan. So that we will write, first simplify it. Secant square theta minus 1 by secant theta, if you take LCM, secant square theta. Under root secant square theta minus 1 by secant square theta. If you take cross multiply, if you make cross multiply, 1 is secant square theta minus 1 by secant square theta. So secant square theta minus 1, it is nothing but tan square theta. Tan square theta. Again here secant square theta is equal to 1 plus tan square theta. 1 plus tan square theta. So this is sine in terms of tan. So that is under root tan square theta by 1 plus tan square theta. Okay. Next step, we have to convert cos into tan. So cos we can easily convert into tan because reciprocal of cos is secant. So cos theta is equal to 1 by secant theta. Secant can be written as 1 plus tan square theta by using identity, third identity. Okay. So that means 1 by under root, not root, under root only. Here under root comes secant, no? It is secant, no? Secant square means 1 plus tan square theta. Secant theta is under root 1 plus tan square theta. So under root 1 plus tan square theta. Okay. Next, tan in terms of tan means same thing will get. Next, tan in terms of cosecant. Cosecant means first you have to convert into reciprocal of cosecant is sine. So cosecant theta can be written as 1 by sine theta. Sine we already converted into tan. So 1 by sine is reciprocal of this one, right? So under root 1 plus tan square theta by tan square theta. Okay? Any doubt? So under root 1 plus tan square theta by tan square theta. Cosecant in terms of tan. Next, secant in terms of tan means it is get directly. We will get directly because we have identity. Secant theta is equal to root of 1 minus tan square theta. Finally, cot. Cot is a multiplicative. It is 1 by tan theta. Multiplicative means reciprocal of tan. Reciprocal of tan is nothing but cot. So, clear? Next, sine in terms of cosecant. Sine in terms of cosecant we write. So sine in terms of cosecant is not nothing but reciprocal of cosecant is nothing but sine. 1 by sine is equal to cosecant. Cosecant theta is equal to 1 by sine. So 1 by cosecant theta. Next, cos in terms of cosecant. So cos in terms of cosecant, how we can write cos theta. Cos theta. First we write in terms of sine. Under root 1 minus sine square theta, and sine is a reciprocal of cosecant, so that we can write under root 1 minus 1 by cosecant square theta. 1 by cosecant square. If you simplify cosecant square theta minus 1 by cosecant square theta whole under root. Okay, this cos in terms of cosecant. So cosecant square theta minus 1 by cosecant theta. Clear it is. Now tan in terms of cosecant. Tan in terms of cosecant. Carefully observe how to convert tan in terms of cosecant. So tan theta is equal to sine theta by cos theta. Sine theta by cos theta. So sine we can easily convert into cosecant, but cos we already converted here now. So cos and sine both is substitute there. We will get tan in terms of cosecant. So that is sine 1 by cosecant theta. 1 by cosecant theta. For cos, under root cosecant square theta minus 1 by cosecant square theta. Here square root gets cancelled. So reciprocal will be right hand. 1 by cosecant theta into cosecant theta by root of cosecant square theta minus 1. Root 2 square gets cancelled. This one gets cancelled. 1 by cosecant square theta under root. Okay. So here what it comes, tan in terms of cosecant. 1 by under root of cosecant square theta minus 1 here. Here minus 1 having no. So cosecant square theta minus 1 comes. So okay. Next, cosecant in terms of cosecant means same thing we get. Cosecant theta only. Next, secant in terms of cosecant. Secant in terms of cosecant. So secant can be written as 1 by cos. Cos already written in the form of cosecant. So reciprocal of this one. 1 by cos means the reciprocal of this one you have to write. So reciprocal of this one. Tan square theta. So okay. Here cos theta in terms of cosecant theta means here square comes. Because the root of 1 minus sin square theta can be written 1 by cosecant square theta. So cosecant square theta minus 1 by cosecant square theta. If you remove the root, cosecant theta will come. Okay. Next one. This also will written now. Which one? This one. Tan theta. Sine by cos. For sine this one. For cos this one. Reciprocal we are writing. Both will cancel. Remaining thing will get this one. Next is secant. Secant first we have to write in the form of cos. Cos can be written as this one. 1 by cos. Cos means this one. Reciprocal of this one. Square root gets cancelled. Cosecant theta by under root of cosecant square theta minus. Next, cot theta. So cot can be written as 1 by tan theta. Tan we already got now. So reciprocal of this one. Root of cosecant square theta minus 1. Okay, clear? Okay, next secant theta. So secant theta, sine in terms of secant theta. Secant is a reciprocal of cos. No, first you have to convert into cos theta. Sine. Next, sine is converted into secant. So secant you see 1 by cos. First sine you convert into cos. Root of 1 minus cos square theta. Sine can be written as root of 1 minus cos square theta. But 1 by cos is nothing but secant. And cos is equal to 1 by secant. Cos is equal to 1 by secant. In the place of cos, we write 1 by secant square theta. This will become secant square theta minus 1 by secant theta. Root square gets cancelled in the denominator. So we will get root of secant square theta minus 1 by secant theta. Secant theta. Okay. Here also root square if you want to cancel, cancel it. Tan square theta under root having no square root if you cancel, you will get here root. Okay. Here also if you want to remove the square, you confine the root to the numerator only. Okay. Here also if you want to remove the square root cancel, root for only numerator. Okay. Next, coming to next cos in terms of secant. It is reciprocal of 1 by secant theta. 1 by secant theta. Next, tan in terms of secant. So identity. Secant square theta minus tan theta is equal to 1. So tan theta is equal to secant square theta minus 1 under root. Tan square theta is equal to secant square theta minus 1. Tan theta is equal to under root of secant square theta minus 1. Next, coming to cosecant theta in terms of secant. Cosecant theta in terms of secant. So cosecant can be written as 1 by sine. Sine already we written in terms of secant, no? So in the place of sine you have to keep this one, and reciprocal of that one you will get in terms of secant. So secant theta divided by under root secant square theta minus 1. Next, we have next one secant in terms of secant, same thing you get secant theta only. Next, finally cot theta in terms of secant. So cot we already converted into tan now. Tan we retain in terms of secant. So 1 by tan. So 1 by this one will be 1 by root of secant square theta minus. Okay. Cot is equal to 1 by tan theta. Tan theta already we converted into root of secant square theta minus 1. So 1 by that one is it. Next step, sine in terms of cot. Sine in terms of cot theta. So sine first you convert in terms of here tan already we converted. No? Sine is the reciprocal of cosecant theta. So sine theta is equal to 1 by cosecant theta. 1 by cosecant theta. So here cosecant theta can be written as under root of 1 plus cot square theta. So 1 by under root of 1 plus cot square theta. So sine in terms of cot theta, because sine is a multiplicative, that is a reciprocal of cosecant. Cosecant is a reciprocal of sine. So sine can be written as 1 by cosecant. 1 by cosecant. Cosecant identity we have secant square cosecant square theta minus cot square theta is equal to 1. So cosecant square theta is equal to 1 plus cot square theta. Cosecant theta is equal to root of 1 plus cot square theta. Next, cos in terms of cot. So cos we can write in terms of cos. In terms of cot, sorry, in terms of cot. So cos we can written in terms of sine. Cos can be written in terms of reciprocal of secant. No? Secant already we converted, not converted into tan. Tan we converted. Secant we converted into tan. No? So cos is a reciprocal of secant. 1 by secant. So okay. Now secant can be written as under root 1 plus tan square theta. Already we did this one. So secant can be written as 1 root of 1 plus tan square theta. That only I written in the place of secant. I wrote root of 1 plus tan square theta. Tan is a reciprocal of cot. Tan is a reciprocal of cot. So in the place of tan you have to keep 1 by cot square theta. So LCM you take, cot will goes up, root square cancel, cot theta by under root of 1 plus cot square theta. So this one comes cot theta by under root of 1 plus cot square theta. Okay. Next, tan. Tan you have to convert in terms of cot means 1 by cot theta is nothing but tan theta. Next, cosecant. Cosecant means it is identity having cosecant square theta is equal to 1 plus cot square theta. Cosecant theta is equal to under root 1 plus cot square theta. Next, secant in terms of cot. Secant can be written as secant theta is equal to under root 1 plus tan square theta. So this tan again 1 by cot square theta. This will become 1 plus cot square theta under root by cot theta. Okay. So this one I have to write. Secant in terms of cot. Under root 1 plus cot square theta by cot theta. Finally, cot theta in terms of cot theta means same thing with it. Okay. This is the 6 trigonometric ratios in terms of other ratios. Okay.